My name is Antonio Azevedo. I am a professor at University of São Paulo. I teach soil mineralogy, soil genesis, and classification. My area of research is soil mineralogy, and my main research right now is about application of rock powder in soil. There is a law just passed a few months ago in the government allowing agricultures to spread rock powder on soil to improve fertility. We are researching what are the changes in primary minerals that could release plant nutrients and toxic elements and improve the soil acidity. This comes in the same direction as improving sugarcane crops, because we rely on alcohol to move about 25 million vehicles on country right now. I also do some research on weathering. I'm interested in shallow soils and rock near surface. What are the changes in rock during the buildup of soil? And it's about that. I teach to graduate and undergrads here in Piracicaba, São Paulo, and it's important for us. We are a big country, about 8 million square kilometers, and agriculture is a very important source of resources, economic resources for our country. We rank in the first place or second in cattle beef and coffee, sugarcane, orange, and things like that. So it's important for us to understand better and better the soils to crop and to maintain soils productive as long as we can.
Well, the application of the rock powders, there's a movement of that in the U.S. too. And you said this law is just passed. How is your research showing that there is some difference, or have you been doing the research long enough to determine that? In the U.S. they've been using calcium carbonate for lime for a long time for acid soils, but these other powders that they're talking about for micronutrients, some of these rocks, those are, and you mentioned working on weathering, but some of those are very slowly available, or because of the processes that they have to go through to in the soil to become plant available.
Yeah, well, what we are doing is that we are working with minor companies that green the rocks to using concrete and pavements, asphalt, and things like that. But there is a sort of a powder about silt size that it's for them it's waste. Our longest experiment is 2 years. There are some improvements in exchangeable bases, but we couldn't find any impact yet on the concentration of micronutrients in plant tissue. There is some improvement in pH, but not as good as calcium carbonate. The silicate is an anion that still neutralizes the acidity. And one of the lines that we are following is trying to increase the surface area of grains to speed up the weathering and release of nutrients, but we cannot decrease too much the particle size because it gets worse to distribute. So we are trying to play a little bit with particle shape, trying to avoid the spherical shape, because this is the one with least surface area for the same volume. And it also we have a very weathered soils, very acid soils, which it's some sort of good environment for weathering. So it's an advantage we have, and it also depends on which type of rock. So we are working with basalts and diorites and diabases. So there's a lot of release of calcium and iron and some micronutrients. But we have some. We will start working next year with interesting rock. It's a phonolite. It's about 10 to 12% K2O. So it's a very promising material. And well, the idea is that it won't harm. So it's the idea is to take some material that is garbage for one sector and turn it to useful material in another sector. It has to be very cheap. It can be too expensive, and for sure it will not substitute the whole fertilizer stuff. It's just a kind of side effect to get a little kick in the production, but it cannot completely substitute the fertilizer, at least in our soils, very weathered soils.
Okay.
An interesting thing and surprising things that we are finding is that it's an increase in CEC. Okay. We are still checking that to see if it's just an artifact of the method that we use to measure the CEC, or if it's really something is happening, or the primary particles are developing CEC as they weather, or if there is some precipitation of secondary phase that is producing CEC. We're still checking that, but it's an interesting area. There's a lot of stuff to be done, so it's thrilling.
Muito obrigado.
You're welcome.